Welcome to this detailed tutorial on implementing end-to-end encryption using Java. In our increasingly digital world, securing your data is more important than ever. In this video, we'll walk you through the entire process of setting up end-to-end encryption, complete with code examples. First, let's start by understanding what end-to-end encryption is. End-to-end encryption, or E2EE, ensures that data is encrypted on the sender's device and only decrypted on the recipient's device. This means that even if the data is intercepted during transmission, it remains unreadable. To illustrate this concept, we'll be creating a simple chat application that uses end-to-end encryption for messages. We will utilize Java's built-in cryptography libraries, specifically the javax.crypto package. Let's set up our Java project. You'll need to create a new Maven project. If you're using an IDE like IntelliJ or Eclipse, simply follow the prompts to create a new Maven project. Now, open your pom.xml file and add the dependencies we'll need for this project. Although Java's built-in libraries are enough for encryption and decryption, we could use additional libraries for convenience and testing. Here are the dependencies. Next, we'll need to create a utility class that will handle the encryption and decryption process. Let's create a new Java class called EncryptionUtil. In this class, we've created methods to generate a secret key, encrypt data, and decrypt data. The AES algorithm is widely used and very effective for our needs. Now that our utility class is set up, let's build out the chat functionality. We will create a simple console application that simulates sending and receiving encrypted messages. Here, we have a simple loop where we ask the user for input. Each message they type gets encrypted and then decrypted back to show that the process works. Now, let's compile and run our application. Make sure you have Maven set up correctly. Navigate to your project directory in your terminal and run the following command. If everything is set up correctly, you'll see a prompt asking for your message. Enter a message, and you will see both the encrypted and decrypted form printed in the console. Next, let's discuss how we can enhance our application. Right now, the encryption key is hard-coded and not shared securely. In a real-world application, you would want to securely share the key between users. We can utilize asymmetric encryption for key exchange. With this utility, we can generate a pair of public and private keys. The public key can be shared with any user, while the private key must remain secure. After generating a key pair, you can use the public key to encrypt the secret symmetric key you created with AES. The recipient can then use their private key to decrypt that symmetric key. This makes our chat application considerably more secure. Now you can use public/private key pairs to securely exchange symmetric keys for the actual message encryption. Let's summarize the changes we've made so far. We've added asymmetric encryption for key sharing, allowing multiple users to communicate securely without exposing their sensitive keys. We've also modularized our encryption logic for improved maintainability. Next, let's cover some best practices. Always validate and sanitize inputs to avoid injection vulnerabilities. Ensure that keys are securely stored and transferred, and it's also important to regularly rotate your keys, especially for long-lived applications. As we wrap up, it's essential to highlight that while end-to-end encryption enhances security, it is not a silver bullet. It should be part of a comprehensive security strategy, including secure coding practices, regular security reviews, and user education. Thank you for joining this tutorial on implementing end-to-end encryption in Java. I hope you found it informative and useful. Please like and subscribe for more content. Happy coding!